Hello, this is Mahanda Didia. In this portion of the book on liquid formulation, we continue to cover emulsion formulation using integrated approach to formulation development. In this particular submodule, we'll look at manufacturing of emulsion at commercial scale. We looked at equipment for emulsion processing, such as homogenizer and high shear mixing. Reader is requested to allocate sufficient time for manufacturing process in this submodule as emulsions are complex formulations. Reader is also requested to review Module 7 for mixer tank capacity calculation based on density equal to mass divided by volume. We will not look at detail on the calculation in this particular submodule. Let's look at FDA guideline. This is added here for sake of completeness. In this submodule, we need to look at the formulation as is described in literature. It is important to make phases in specific sequence in manufacturing of emulsion and double emulsion. The process stages clearly identify dispersed phase, continuous phase, and other phases such as active, preservative that are processed as a separate substeps and then combined later on. Just to refresh, calculate volume and weight for each manufacturing stage. Use about 40 to 70% of working volume to select the mixer size. For example, volume of a phase is 100 liter, then mixer size is approximately 143 liter to 250 liter. For each step, specify mixer type and tank capacity. Include a rinse step so that active is completely recovered. Let's look at the video. In this video, you will see importance of the mixer type, tank geometry, and positioning of the mixer. The high shear mixers draw material from the bottom. The material is drawn from the bottom, and rotor stator reduces the particle size and provides uniform mixing. It is important to understand the geometry of the mixing tank to provide efficient mixing. If the tank is very shallow, then mixer will not be located and will not provide efficient mixing. Mixing position needs to be correct. If it's too close to bottom, it will not mix. These needs to be looked at it in manufacturing of emulsion. Let's look at oil and water emulsion of ruxolitinib. This drug was approved in 2022. It is a JKA inhibitor and indicated for atopic dermatitis. FDA documents do not identify exact composition, and it's not implied that this is exact composition that FDA approved. There is a separate literature that has formulation information, and that's used in this section. Let's go to the phases as described. Paraben phase, parabens are dissolved in propylene glycol. Gum phase, xanthan gum increases viscosity. That's mixed with propylene glycol. Oil phase consists of light mineral oil, emulsifiers, white petrolatum, cetyl alcohol, stearyl alcohol, dimethicone, and medium chain triglycerides. Dimethicone here is used as a skin protectant. That's an active. Aqueous drug phase is purified water, EDTA, polyethylene glycol, and the drug. Final is phenoxyethanol preservative. The percent weight to weight are given here, and grams per tube is given. Readers are advised to refer to module 16.1 for stability study of this product. Processing steps and equipment selection. Aqueous phase consists of 3 different portions, separately prepared and mixed. Aqueous portion contains water, EDTA, and polyethylene glycol. Paraben phase contains paraben dissolved in propylene glycol. Drug is then dissolved into the aqueous mixture containing aqueous and parabens. In the gum phase, xanthan gum is wetted in propylene glycol for about 4 hours and then it's added to complete the aqueous phase. Oil disperse phase, all the components are dissolved to form a single oil phase. Emulsification disperse phase is added to the aqueous phase with high shear mixing. Preservative is added to the dissolved emulsion. Homogenization is performed to achieve target particle size. Let's look at the batch formula. This has been rearranged, provides percent weight to weight, provides kilogram for 400 kilo batch. Density from the literature is shown here. Based on this, we can calculate volume of each component and the total volume. 400 kilo batch volume is 406.7 liters. Based on the volume and 40 to 70% capacity, we can calculate the mixer size. 50 liter for gum portion, 100 liter for paraben portion, 600 liter main tank used for purified water as well as entire aqueous phase and emulsion. Oil phase is prepared separately into a 200 liter tank. Preservative is added to the emulsion. We have now rearranged the steps in order of manufacturing or sequence. So let's look at each step. Xanthan gum wetting or hydration for 4 hours. Propylene glycol is added. High shear mixer should be used to disperse xanthan gum. Slowly add xanthan gum over 30 minutes. Continue mixing at moderate speed for about 4 hours. In process would be weight control and clarity. It should be free of lumps. While xanthan gum preparation is going on, other portion can be prepared. Start with paraben portion and 100 liter tank. Add propylene glycol and mix. Add and dissolve metal paraben, followed by propyl paraben. In this case, weight control is an in-process test. Water portion is in the main 600 liter tank with homogenizer. Add water, propylene glycol. Use the main blade mixing to mix at moderate speed for about 30 minutes. Cover the mixer to minimize water evaporation. Add ETTA and weight control should be done. Transfer paraben phase into aqueous phase. Temperature can be increased to 75 plus or minus 5 degrees. We'll continue on next page. Disperse drug over 10 minutes into the aqueous phase. Mix for about 30 minutes. Maintain temperature 75 degrees. This will allow drug to dissolve faster. Transfer xanthan gum phase to the aqueous phase. Mix for 30 minutes. Maintain temperature. Weight control again should be in process control. At this point, aqueous phase should be clear liquid, free of lumps. Oil phase preparation. In 200 liter mixer, add white petroleum and light mineral oil. Heat it to 75 degrees for 30 minutes and mix. White petroleum is a waxy substance. Add cetyl alcohol, and triglyceride. Mix at moderate speed for about 60 minutes. Add emulsifier and mix at lower speed to avoid foaming. Finally, add dimethicone. Maintain temperature to about 75 plus or minus 5 degrees. In process control, visual check of oil phase should be clear liquid. Emulsification. Oil phase is added to the continuous phase. In the main 600 liter, which contains aqueous phase, start the high shear mixer. Transfer oil phase at about 5 kilos per minute. Continue to mix at high rate. Continue to mix and maintain temperature for about 1 hour. Product appear as white emulsion. Stop the high shear mixer and continue to use the blade mixing. Avoid foaming. Increase the speed of main blades to maintain mixing action as viscosity increases. Add phenoxyethanol to the tank. Continue mix for about 30 minutes. Record the loss and if necessary QS to control limit. Cool the final product to 30 C using room temperature water and continue mixing with low shear main blade mix. Transfer to storage tank, conduct quality control sampling, followed by packaging in tubes. Here's typical equipment that can be used for making oil and water emulsion. The main tank with high shear mixing, and blade mixing. 100-liter paraben phase, 50-liter high shear mixer for gum phase, and 200-liter Jacqueline mixer for oil phase. We'll look at the double emulsion sunscreen formula: 400 kilogram oil, water, and siloxane. Just to refresh, double emulsion, core is oil, yellow in this case is water, and outer blue is siloxane. Double emulsion contains three major phases. Shell phase, in this case is water. The core phase, in this case is an oil phase. And siloxane phase. Both sunscreens are incorporated in the siloxane phase. Let's look at the formula. It has purified water, humectant, preservative metal paraben, carbomer as a thickener, glycerin, and emulsifier with high HLP. Oil phase contains mineral oil, three different emulsifiers with low HLPs, preservatives, and primary emulsion is made OW, oil in water, and pH is adjusted using triethanolamine. Color and fragrances are also added. Siloxane phase has several different types of siloxanes as listed here: cyclomethicone, dimethicone copolyol, cyclomethicone, dimethiconol, cyclomethicone, and phenyl dimethicone. Emulsifier is Barrett 15-3. Sunscreens are shown here, and solubilizer is alcohol benzoate. Formula is given in percent weight to weight, and 400 kilo batch formula is shown here. Overall emulsion stages and equipment. There are three separate phases here: siloxane phase with active, core phase oil, shell phase aqueous. Other phases are pH and colors. The primary emulsion, in this case oil, water, needs to be freshly prepared and added to the siloxane phase. In double emulsion, we start with the preparation of the continuous phase in the main mixer with homogenizer. Primary inner emulsion is prepared by adding core phase, in this case oil, into shell water, and is hooked up to a high pressure homogenizer to achieve submicron size. Preparation of double emulsion: primary emulsion freshly prepared directly into the main tank. Let's look at the mixer capacity for each steps. In this case, formula is copied as is. Mass, densities are shown. For low volume, I've used estimate of 1 for calculation of the mixer size. Aqueous phase, 263.1 kilos. Total volume is 259 liters. Oil phase, the core, is 13.6 kilos. Volume is 14.12. Oil and water primary emulsion, weights and volume are shown here. Siloxane phase, weight and volume are shown here. And total double emulsion, 400 kilos, is 412.8 liters in total volume. Based on these volumes, we can calculate the capacity of mixers needed. Here are the equipment size for 400 kilo batch. Oil phase in a small mixer with scraper as well as main mixing blade. Shell phase, aqueous phase in a 600-liter mix. Final can be done in a separate mixer with inline homogenizer and high pressure homogenizer attached to the primary emulsion and then placed into the 600-liter mix. It requires extended shaft with homogenizer to make sure siloxane phase is completely mixed. Let's look at preparation in hypersequence. Prepare siloxane phase before starting other phases. That's a continuous phase. Freshly prepared primary phase will be added to the continuous phase. Siloxane phase will be in 600-liter main mixer with a high shear as well as low shear mixing capability. All siloxanes are added, mixed at moderate speed until single phase is obtained. Maintain temperature between 25 and 35 degrees. Mix alcohol benzoate, add octyl toxycinnamate and benzophenone 3. Add Perret 15-3, the emulsifier, mix at low speed and avoid foaming. In process, a single clear siloxane phase is obtained and there's a weight control. Continue mixing at low shear until completion of the entire process. In parallel, we can prepare aqueous phase and the oil phase. Aqueous phase is in a 600-liter mixer with high shear homogenizer. We add purified water, increase temperature to 70 to 75, cover the container to minimize water loss, add ingredients, dissolve metal paraben, add carbomer slowly over 15 minutes without creating lumps. In process, check should be clear liquid, free of lumps, and a weight control. QS with water to achieve weight control within limits. Oil phase is in 25-liter. Heat heavy mineral oil up to 80 to 85 degrees. Add emulsifiers and other ingredients and mix for 30 minutes. Add propylparaben, ethyl paraben. In process control, clear liquid with a weight control of 13.6 plus or minus 0.1 kilo. Start primary emulsification process only after the completion of preparation of siloxane continuous phase. Start high shear homogenizer in 1600-liter aqueous phase vehicle. Add oil at a rate of about 1 kilo per minute. Bring temperature to 70 75. Mix for 60 minutes. Stop high shear mixing. Continue to mix at moderate speed using main mixer to avoid air entrapment. Cool to 60 to 65. Add triethanolamine. Add purified water to achieve weight control limits. Cool to 35 to 45 degrees C. Add colorant. Emulsion at this point will be uniform red color. Mix the flavor and cool to 25 to 30 degrees. Primary emulsion must be used fresh within 4 hours. Double emulsion OWS. Continue mixing siloxane phase at low to moderate speed and adjust speed as final product viscosity increases. Maintain temperature between 25 and 35 C. Attach inline homogenizer and high pressure homogenizer to the outlet of the primary emulsion mix. Add the freshly prepared oil and water primary emulsion, passing through homogenizer and high-speed homogenizer at rate of about 5 kilos. Mix double emulsion at low shears, mixing to avoid breaking of an inner emulsion. Mix for about 60 minutes to homogeneous double emulsion oil, water, and siloxane. Cool to temperature 25 to 30. Weight control 400 plus or minus 2 kilos. Transfer to holding storage container for packaging.